Do you have homework questions, or do you want to start with the review stuff that I put together?
That was so nasty. What? I know.
Preference, anyone? Rita?
I should like general question.
Sure.
So when you're doing like the use of, when do you have to change the
So you can do it always, or you can do it never.
Oh.
So if you're doing a definite integral with u substitution, you can, when you make your u, you can use that to change your bounds of integration, and then you don't have to plug the x back in for your u. You can just, after you do your antiderivative, you can plug your new bounds in and go. Or you could leave your bounds the same, and after you do your antiderivative, you have to plug your x's back in, and then do the rest of your definite integral. Either is okay.
because I was doing without that, I was like, am I supposed to be changing it?
Yeah, so you can or you can't,
Okay.
right? Like, it doesn't matter. You get the same answer either way. Oftentimes, if the u is complicated, it makes life a lot easier to do the change the bounds. So you don't have like a mess to sort through at the end, particularly if it's a no calculator situation, because it just kind of like helps chunk the problem a little bit for you. But you don't have to.
Okay, that was
Beck.
13 from 7-8.
7-8, number 13. Sure. All right. So first thing I want to do for number 13 is I notice that I have both the upper and lower bounds are infinite. So I want to start by breaking that into two separate integrals. Typically, I'd want to go and break it at 0. Tends to be the most convenient place to do that. Oops. But it doesn't really matter. You can kind of take your picks. So do that. And then we'll turn this into a limit problem. So introduce like a new kind of dummy variable t. And I'm going to use the same t in both they're different t's, but I'm going to use the same letter t. Achoo! Well, yeah, thank you. You could use a different letter, though, on the second one if it confuses you. So far, so good. So now I'm going to go ahead and do my antiderivative. So this is going to be a u substitution problem. So I'm going to have u equal negative x squared. So if I do that, x dx has to be du over negative 2. And I'm going to use the same substitution both of these, right? Since they're the same integral other than the bounds. So we have the integral t to 0 of e to the u over negative 2 du. That feel okay there?
Is that negative?
No, that's just messy. So we'll do our antiderivative now. that we've got our u sub set up. Now the antiderivative is easy to do. So that's just going to be e to the u over negative 2, right? And I guess at some point we'd have changed the bound since we're doing a u sub, but I'm just going to not, because it feels like it's just going to be a lot of changing kind of going on. So I'm just going to go ahead and now put my x's back in. And I'll finish doing my definite integral. So that's going to be, when I plug 0 in, I just get negative 1/2. And when I plug t in, I get that. So I'm here. Everybody so far so good? So let's start doing our limits. So the limit as t approaches negative infinity of negative 1/2, well, that's still just negative 1/2. And then the minus and negative I'm going to turn into a plus. What's the limit as t approaches negative infinity of t to the negative t squared?
0.
Good. That is 0. Because really you can think about that as 1 over 2e to the t squared. Right? And if we're going to negative infinity squared, or negative infinity squared is going to be positive, huge number. 1 over positive huge is 0. Everybody's okay there? Okay. And we go over to the other side. Again, we get 0 and then plus 1/2. So this comes out to be 0. Just double check to make sure I did that right. But that feels pretty good because I think this thing is gonna, yeah, I don't know. 7, 8, that's what section we're in. Do we make a boo-boo in there? I don't know. Doesn't feel like it, but that's the answer from the back of the book. Awesome! Well, then I feel really good. Rita saved me the hassle. Anytime you want to do that, feel free when I grab the answer book to start flipping to make sure we did it, but good. Back to that.
Yeah, back there. Thank you.
Yeah, no problem. Elena.
I have like kind of a generalized question.
Sure, go ahead.
On the test, is it going to like set up like you're going to do like 5, like give us 3 problems, or is it kind of like we should look at it and just know what to do?
You should look at it and know what to do.
Okay. So it's not going to be like set up.
It's not going to be organized by section. I know, that's rough.
Are there directions?
Well, it says like evaluate or like do the integral.
So yeah, how do you know when you're solving for the area under a curve? Like, was it the indicator?
Oh, you mean the area between two curves?
Yes.
Well, that direction will be specified,
Oh,
sure.
okay.
Yes.
Okay.
Yeah. For sure. It'll say calculate the area between the two curves or the volume of revolution or like that much would be prompted in the
Okay.
direction for sure.
That's what I'm confused about.
Yeah, no. You Isabel. Sure. Let's take a look up here. 9. So here I'm going to start just by turning this into a limit problem since there's only one infinite bound. And this is a U sub problem. Oops, I don't mean dx though, right? I mean dp. So when I do my substitution, bless you. So far, so good. Okay, we'll do our antiderivative. Which is real easy because it's just like just e to the x. Now we got to plug our, bless you. Since we didn't change our bound, we have to plug our bound back in. Won't really matter here. Well, I guess it will because of the stuff. Anyways, yes. So we do that. And now we finish doing our definite integral. So we'll plug t in for p. And then plug 2 in for p. So far, so good, Isabel? Okay. So the limit as t approaches negative infinity of e to the negative 5t over negative 5 is no. It's not 0 because the exponent is going to be a positive number when we plug negative infinity in. So it's negative 5 times a negative number. So you're going to end up with a positive exponent. Yes.
Why did you switch from t approaching positive to t approaching?
Oh, I don't know. That's a great question. Yeah, so if it's positive infinity, then it does go to 0. My apologies. Yikes. Thank you. And that's just my answer. I guess you could type that in your calculator and get a decimal if you want. I think e to the 10th over 5 is just fine. Does that feel okay, Isabel?
Yeah.
Thank you for catching my mistake.
I just have another question.
Yes.
So on the test, like, for the volume questions, are you gonna ask us to like fully integrate like or equation, or you just put it into the calculator?
So all the questions are going to ask you to draw a picture, set up the integral, and solve with your calculator. Katie.
Do you have like any regular just like subs or alternate like
Nope, there could be regular U subs, right? Again, 3 general U sub problems like from 5.5. Expect to see single and double substitutions. 3 rational function U subs, 1 improper integral. Is that okay? I think these are going to feel just like your standard run-of-the-mill problems.
So
Yeah.
all of the examples we do on OneNote, we should be pretty like
I would-
well-rounded?
I would think so.
Okay.
I would think so. Rita.
Do you think we should like still like go through all the MCQs, or should we focus more on?
Well, most of the MCQs are just homework problems with like A, B, C, D. There's not a lot of conceptual stuff in the MCQs, right? So it's fine to look at those, right? The place where I would look at those is like these geometric cross-section ones that are just like a little bit different than the things we saw in the text. Like those ones I'd want to look at for sure. So I'm like, oh yeah, I remember how to do this. They're not bad once you have the hang of it, but there wasn't a lot in the textbook that resembled that.
Yeah.
So that would be the one place where the MCQ stuff I would definitely want to look at.
And what that part is.
I wouldn't worry about it. Okay. Do you want to see my cool PowerPoint that I made?
Yes.
It's not really a PowerPoint. It's a PDF or whatever that I made. Okay. So I have just like kind of an example from every section. Give it a shot. We'll give you guys, take 5 minutes or so, and then we'll kind of go through them. Again, don't worry about if you don't finish, you don't finish, not a big deal. I'll kind of walk through some of the, not every single little nitty-gritty detail, but a lot of the detail. And what you're seeing here, I think, are like representative examples of what you might see on the test. Everybody try and U sub on this. All right. I know not everybody's finished, but let's kind of move forward here so we have time to look at kind of everything that I have listed. So the u you should pick as x plus or 2 plus x. So du is dx. So we got to figure out what to do with the x squared. To do that, I'm going to take my u and rearrange this equation. So I'm going to subtract 2 from both sides to say x is equal to u minus 2. So x squared should be u minus 2 squared. So if I plug that in, I have the integral of u minus 2 squared, square root u. Oh, that should be du. Oopsie. And if I FOIL that out and multiply everything together, I get this guy. And then now I can just do my antiderivatives to there. Yeah, Isabel?
Can you just briefly explain what you did with the x squared?
So with just this part,
Yeah, I didn't get that part.
I still have an x squared, right, when I make the substitution. So I took my u equals 2 plus x, and I subtracted 2 from both sides and say, okay, well, x is u minus 2.
Okay.
So x squared should be u minus 2 squared. So I made a second substitution, and that allowed me to get all u's in my integral. Then I FOILed that out and multiplied the square root in and was ready to do my antiderivative at that point. And then I subbed my 2 plus x back in for my u's.
This is a double substitution.
Yes, this is an example of like a double substitution here. I'm going to pull this up so I can edit those things at the same time. Rita.
How come it says dx?
I made a typo with the dx's. Those are supposed to be du's. Yeah, thank you. Yep. I can't fix it while the PDF is open, but any place there's a u, it should be a du.
Should it be just du or du over two? Or actually, yeah.
Should just be du's.
It's like when you do the. Oh, okay, I agree.
Okay. And I'll post this, I'll drop this into OneNote for you guys. So don't feel like you have to write the whole thing down. Is that cool? Okay. This is probably about the maximum level difficulty of a U sub problem from 5.5 you'd see. Okay, ready to see the next one? Ooh. You should use your calculator on this. This would be a calculator problem. So, yep. See at the top? It tells you what section we're in. Isn't that cool? As I heard somebody mumble, make sure you're in radians, right? Especially if you're a physics kid that's been going back and forth, back and forth, back and forth. I was throwing this together quickly, so I didn't include a sketch in my example or my answer. When you looked at the graph, what did you notice? They switch which one's on top, right? I'll point that out to you right now. You see how they're switching which one is on top and which one's on bottom? You have to account for that when you do your area.
This is really wonky. Am I too zoomed in?
Well, I would, says x goes from 0 to 2 pi, so let's just make that 0 to 2 pi, right? On our x min and x max here.
Mm-hmm.
And then I would probably not go from -10 to 10, since I know that these things, the biggest any of them could be is -1 or +1. So let's do that. And that probably will give you a better looking picture.
Beautiful. Thank you.
You're welcome.
So do you think the easiest way to find that intersection is just talk with the calculator?
You can certainly do that.
Okay.
Unless you really remembered your trig identities. If you wanted to do this algebraically, your hint is that sine 2x is equal to 2 sine x cos x. If you wanted to try doing this algebraically, you'd need to remember that sine 2x is equal to 2 sine x cos x. That's your double angle identity for sine, which you all memorized last year in trig and pre-calc, right? I don't think anybody would expect you to have that one memorized, but other than me. What'd you guys get for the intersections?
5 or 6.
Mm-hmm.
That only have one.
That's good. 5 or 6 is your boundary where they switch which one's on top and which one's on bottom. Oh, pi over 3. Did I just screw this thing all up? Wait a minute. Yeah, I might have. Rut-row raggy. Rut-row raggy. You guys big Scooby-Doo fans?
It's valid.
Yeah, I sure did goof that up. Hey, ignore all this mumbo jumbo. That's all wrong.
Right.
1/2 should be the answer. I'm gonna fix that so when I post this for you guys, it's fixed.
How are you gonna do? How are you gonna? Yeah. So, how would you do like? I mean, let's say what's the antiderivative of sine? Negative cosine. So then you still have to plug in negative cosine 2 times pi over 2. That's just pretty difficult. Yeah. Did you get to 1.5? Were you not touching it right? Because like when you're writing that, the letters connect. Mine did that for a while. I got like a new thing.
So you should have gotten 1/2 there. My apologies. This is all wrong. So the boundary would have been pi over 6. You just set the two equations equal and find the intersection. Well, this is from the calculator section, right? These are calculator problems. I'm intending you to use your calculator.
I got a decimal and then I just pi divided by 6, pi divided by 4 until I found the right one.
Sure. Or you could just use the decimal and it'll be fine, right?
I just didn't want to write out all those decimals.
If you wanted to do this algebraically, cosine x is equal to sine 2x. Sine 2x is 2 times cosine x times sine x. Subtract cosine x from both sides, factor the cosine out. Do your zero product property, break your 2 trig equations.
Yeah.
You get 3 solutions or whatever.
Can you explain the 1 minus cosine x?
It's wrong.
Oh.
It's wrong. I wrote down the wrong thing. So you have the integral from 0 to pi over 6 of top minus bottom dx plus pi over 6 to pi over 2 new top minus bottom because they switched the top and bottom. That's it. And then it's calculator time. Should get 1/2.
So pi over 3 and pi over 6.
Pi over 6 to pi over 2. Isabel.
When you graph it, there's so many lines overlapping one another. So how do you determine what you're trying to reach is?
I would look at x min as 0 and x max as pi over 2.
Minus.
Well, even then, there's like a bunch.
Okay, DS. DS. Let's see.
I mean, there should only be like 2 places where they intersect.
Like, couldn't it be like this area under here?
No, because that's not between the 2 curves. It's that and that. Between the 2. Right? So between the red and blue is there.
Oh,
between blue and red is there.
Okay, got
It's
it.
got to be between the curves, not under, between. All right.
Wait, so what do you do once you hit the pi over six?
Top minus bottom.
Edgar Allan Poe.
And then you do.
I'll fix it and post it. I promise.
Would this also be a calculator?
Yeah.
Okay.
We'll see calculator problems from here on until I tell you to put it, that you don't get them anymore. But all these, like specific graphical.
Tablet keeps talking. We started 5 minutes.
What was the answer solution?
1/2. Did you switch the top and bottom?
For the second one should have been like the bound like from pi over 2 to pi over 6.
Pi over 6 to pi over 2, but the function on top switched.
Yeah. Oh. Wait, no, I did my.
I suspect you did like,
Did you do pi over 2?
did you do cos minus sine x in both integrals?
Ah, got it. No, I put pi over 2 on the like.
Oh, so here's a volume problem. Again, use your calculator. Use your calculator to do your graphing. Use your calculator to do the integral. Mm-hmm.
Intersection points and points. So we're 2 and then whatever the line is. That would be like your copper buffer.
think I should have put in x equals 0 also here, right? I think so. So there should be an x equals 0 here also, right? You need something there since it goes.
Would we normally get that, or would we just find it?
No, I should have written it. I just forgot to, I think. I tried throwing this together in just like a few minutes yesterday, and it apparently didn't go real well for me. I didn't have time to proofread it. Who's trying to use a washer here? That's good.
Oh, my tablet restarted. Above the curve between white and like it. This area. Yes.
It's probably easier way of writing it.
Yeah. Just hitting the restart in 5 minutes.
Oh.
Can you draw this one?
Yeah, one moment, please.
How did you get that formula?
I simplified
Oh,
r outer squared minus r inner squared. I don't know why I did it that way.
okay. There's gonna be one time in the class I forget to add the pi.
It happens to me all the time. Okay. So this is like your shaded region here.
Oh. You have to do them separately.
What did I-
Separately. It's r outer squared minus r inner squared.
Wait. Oh my gosh, guys.
So what you get? Did you get it?
No, this isn't right.
Let's see what you did.
R outer. 1 second here, guys. Oh, okay. Shoot. There we go. So that is probably right. So you're talking about the area between right here. This is your shaded region, right? Everybody's good? Okay. So my R inner is this distance, which is constant, right? And my R outer is this distance. Isabel?
When you plug in,
You have to pretend like that's the.
when you do like 2 minus
That's.
and negative x, because it's like a that's like your radius and you squared it,
The
you
value
FOIL,
of.
like,
That's how I ended up with this. Yeah, I foiled out and simplified. You don't need to do that to type into your calculator.
But to get from there,
well, but
we
we're-
have to do
it's either that
2,
the x
which is
that's
where our
over
axis
there,
is,
or the x is like
minus the point on the right.
It's negative 2x.
So that's that.
You add
That
exponents.
would be your outer. And then our inner is just 1.
Katie,
wait, so what's the R?
Is-
R inner is 1.
Our radius is
Oh,
just
so
1.
this distance from y equals 2 to y equals
Distance
1
from 2 to 1.
is my R inner. And this distance from y equals 2 to the function is R outer.
You're looking. So, here's our, like,
Y equals 2 to the
This
function
is our axis of rotation.
is R outer.
That's y equals 1. And that's our thing. So when you rotate it, this is the shape that you make, right?
I did it. I did it.
Yeah, so then that's our axis of rotation.
The axis of rotation is y equals 2,
Radius here.
right?
I was looking at it as the
Oh, I right.
Yeah,
That's why
so that's gonna be 1, and then our outer is
I just
2 minus.
I thought it was this shaded underneath. Well, that's why that makes sense.
Yeah,
I was like, well,
yeah,
thank you.
of course, I got you. What is Billy's back 9?
So I used to coach a cross country team, and they found that on a run and decided they need to bring it back. It was like in a garbage pile, you know, that golf course north of Giddings,
Yeah.
or on Giddings, like
What is it called? Yeah.
they found it like a garbage pile on the side of the golf course.
Billy's back 9.
And they're like, "Oh, here, you need to have this." I'm like, "What am I going to do with it?" We were putting in your classroom. It's like, fine.
How long has that been there?
I don't know, 10, 12 years.
Wow. I wonder what Billy's back 9 is.
I assume it was like I assume it was like the snack bar at the turn on the golf
Yeah,
course.
Probably.
But
That makes a lot of sense.
That's my guess. All right, let's try another.
That makes so much sense.
It's at 9.5. Yeah.
Where do they?
Do you multiply by 5?
Reed, it sounds from like experience. You've made that mistake a couple of
I
times.
just did actually. And I got 3, that's all I got.
Yeah, that sounds right.
Yeah, that's it.
Again, these problems should feel just like homework problems, right? Like nothing shocking, like nothing tricky, nothing weird conceptual. This is just like, can you do the problems? Yes. Well, it's not an area. It's a volume of rotation.
Yeah.
But yes, that's the shaded region.
I got.
Gotcha.
I knew what you meant. But I want to make sure that we're clear.
Could be wrong on that. That'd be a trick stick. I did 2 pi and then did 0 to 1. I did 2 pi and then 0 to 1 for my interval. Points. Because it was like symmetrical.
Oh, sure. Yeah. Yep, you can do that.
It makes me feel like I'm better at this.
It's like that stuff becomes, the further you go, the more useful that becomes, because like sometimes it's just like a nightmare.
Yeah.
Oh, yeah. Wait, that's why.
You should be using a disk to do this, yes.
Yeah, it's very like, it's not conceptual. But it's very like,
Mhm.
It's the X in this case, right?
The 37 through 45 that we were doing together.
Yeah.
That wasn't that bad.
Again, it's once you've gotten the hang of this, they shouldn't feel that bad, right? You can still catch a tough one every once in a while, but like the average problem should feel pretty doable. And I'll tell you what, like done a lot of AP exam questions, there's not a lot of like nightmare ones on actual AP exam stuff. Because they're just trying to make sure you can, it's timed too. So like you need to be able to do it in a time setting. So we can't make this like nightmare hard.
Right.
Has to be something that's doable and just checks to make sure that you can do it.
Yeah.
Like that previous one where you have to do like the 2 minus the function, like that's enough, right? You don't need to do that for both of them.
And you can only make it so hard conceptually, and then it just gets to a point where they're making it like tedious.
Yes.
Where
Yes.
it's like, oh, I know how to do this, but it's going to take me 10 minutes to write it all out.
Right. Or you catch like this is an appropriate no calculator problem because it's not like the calculus, the algebra would not be brutal. The previous one,
You would have to do a
Would
heat
have-
sub on this, right? Or could you just
you could foil it out.
just distribute?
Yeah, you could foil it out and just be fine. Katie, what's up? Oh, okay. That's it. Could you do the symmetry thing? Sure. Could you write this as 2 pi and then 0 to 1?
Where did you get negative? Oh, that's the X. Oh, okay, I had it written down, just spelled interval. Forget.
Okay.
I just feel so good about it. when
Back.
I see it on the
Sorry,
board
it's
and then-
unrelated, the other symmetry rules if it's an odd function, it's 0, right?
Yes.
Can I see your picture?
It's on
Never mind.
It's just like a little circle in the middle of it. For this one.
the picture right there. Wait. Oh my god.
Honestly, integrals have been my favorite thing we've done.
Speak for yourself.
What was your least favorite thing?
First chapter.
Yeah, first chapter here.
Yeah, it's the only time. But then I laughed behind it.
Well, like, if you go back to it now, like, you would love to
Those
go
are
back to it
fun.
now.
I didn't think so at the time, but.
So I sucked at physics.
What's up?
So the bound is -1 to 1.
Because we are between this curve and the x-axis, so you need that x-intercept and that x-intercept are going to be our bounds of integration.
Oh, my window is just too small, so I didn't grab it.
What's up? Vertically, because you're integrating with respect to x. So you're slicing, your increment slices are moving horizontally.
So how do you know which one to integrate?
So if you're rotating about like a horizontal, that means that the circle you're creating is like this way. So you have to slice perpendicular to that. So as you're slicing, you're moving from left to right.
You
So you're integrating with respect to x if you're rotating about a horizontal for disc and washer, right? If you are rotating about a vertical, so your circles are this way, right? So you're integrating with respect to y if you're rotating about a vertical for disc and washer.
Don't forget, like I did in algebra. Like in algebra, we would do a chapter and then go on to the next one, and I forgot everything that we did before. So
This year it's so punishing if you do that. Because
Yeah.
it's just like, oh, yep, you have to remember this integration rule or this derivative rule or like this, like they never really go away. It's still
keep
like,
using them, so it kind of helps with that too.
yeah.
To be honest, I think I forgot a lot of those like trig, like derivatives and antiderivatives.
I go back and go back and use every single thing.
Yeah, so I'm gonna need to go back. I remember like the basic ones, like
Next one.
Yeah, and like 1 over 1 minus x squared is tan inverse. I not remember because
No, but like now it's the full picture.
Wait, what do you think?
that doesn't even answer my question. Like I don't even know. I don't know which area we're in.
Yeah.
Sorry. Yeah. This is the first quadrant. So, yeah, that's probably not enough. So between that and, what do I want to see? That's not enough information, is it? Oh.
I like that. Go between the curve and y equals 1.
No, because it's periodic. We need to have we need a horizontal. We need a. So let's say between 0 and square root pi.
Okay.
Yeah.
Is that an x value?
Yeah.
And we're still going about x equals 0?
Yeah.
Okay. Dude, my neck like spasms out.
Why did I pick square root pi? What do you get when you plug that in?
Something.
If you plug square root pi into the function, you get
Probably something good.
0. Right?
Wait, what?
Sine of square root pi squared is sine of pi, which is 0. So just your x-intercepts, right? 0 to square root pi are just the first 2 x-intercepts. I'll update that. So when you look at this again later.
We're slicing with respect to y.
Mm-hmm.
I'm like having a brain fart right now.
No, this is, what should we be doing for this? Yeah, this has to be shell.
It's like the 2 pi r h.
Wait, why am I like drawing a blank right now? So do we have to like flip the function and put it in terms of x, right? Don't have to?
These are the directions that give us too, right? So that's the reason if I go you want
Wait, what are your like bounds on your? For which one? For this one, 2 pi r. Like why'd you put 1/7?
That's the square root of pi.
Okay,
Oh, I did that. I didn't
so
do that.
radius is gonna be
I just typed in literally square root pi.
that.
That's what I did. Don't we need a hole? Like, is there even a hole in this one?
There it is absolutely convex. Yes.
Wait, what is h equal to again?
Or concave, excuse me. So the h you always draw through the shaded region.
Right.
So like if this is your radius to here, your height would be up from there through the shaded region.
Okay. Yes. So we have to solve
Hands are
for,
up just yet.
or no?
And the height is then your
Oh, wait.
y.
Yeah, so it's just gonna be x for the height.
Oh.
Uh,
Just be like,
no, the radius would be x.
yes, that's what I meant. Sorry.
Okay.
No, I accidentally drew my axis like this and not this. So I was like,
No,
oh,
said you don't,
there's
because
no
it's a shell.
hole. I'm looking at that and then that's
So how do you write it in your radius?
What?
How do you write the radius?
Oh, just whatever our x value is.
Oh, it literally does that.
Okay. So
'Cause you're going
x
from
equals 0 is our axis of rotation, right?
Yes.
So my cylinders are going to be, so this thing is like, has a flat bottom, right? And then has like a cave in in the middle, right? It's like a, you know, like a donut when you hurt your butt, you have to sit in it. Except it's like, still has a bottom. So when I draw my radius for my cylinders, every cylinder is going to sit along this bottom, right? So the radius of my cylinder, like to here, well, that's just the x value of the function, right? Just the x coordinate for the function. So it's just x. And the height would be, you know, if that was my radius, it would be here, right? So which would be the y coordinate for the function. Yes.
No, you're doing x. So it's 0 to 0 to 5.
Oh, I know, never mind, I got it. I was just looking at it.
Oh, I forgot.
Yes, I did.
I forgot for the shell method. It's
Yeah, because it just ends up being one.
shell method is the max, or like the max radius of the shell, right?
Correct.
Thing.
Yes.
If you would have given us the square root.
Yeah. Yeah.
And the thickness of it is dx, right?
Correct. Yeah, you're basically, it's like a Russian nesting doll, where like
Right.
the thickness of the doll is the dx,
Okay.
except it's Russian nesting cylinders.
I didn't until he told me.
So this is why, Lorenzo. So if I try to do a washer here, this would be like my inner radius, and then that would be the outer radius, but it's the same function. How do I write? Like I'd have to find a way to resolve.
Is it possible? Just very difficult, right?
Yes.
You would have to like
You'd have
find
to.
where they're equal to each other, like the values where x, y is equal to each other, and then do it like the latter one.
Yeah, it would. You need to find the maximum, like where the maximum happens,
Right.
and they need to be like restricted. Okay, so like this, our outer is, you know, this value, you know, north of this value. It's a really difficult
Right.
to kind of like walk through it algebraically. The shell is just like, look at how easy it was once you got the setup. It's like, oh, that's
That's your bound.
Right.
There's like,
My neck is killing.
there's like, so when you rotate it on your axis, there's this.
Tuesday last week.
Space in the center, right? And then so you're finding the radius,
They
which is
said
your
it'll take
axis in
8
relation to your function. So like that's x, this is the distance.
No, until I don't have pain.
Does that make sense? Like that's your radius.
It's as far as I can tell.
Thanks. And then your height is just, I mean, the height is what you
I could have, you're right.
And then your bound is like, this is where it stops. So your bound, like, that's x. This is your which is
It makes
your-
so much sense when I see it.
Is that your worst fall ever?
When I don't have the answer.
Worst fall ever.
It makes sense when someone else
Yes.
explains.
Well,
Yeah.
here's the good news.
Injury.
You have like 3 of these problems, these volume problems, right?
That's like.
Hold on. You have like 3 of these volume problems, right? What do you think you're going to expect to see?
One washer, one dish.
One of each, right? So at least like if you know, hey, I can do this as a disc and do this as a washer, well, this one must be the shell one. You know, like you can help process cell of elimination yourself through that, right?
True.
So can you just explain like what we should look for to like identify each 3?
Sure. So if I think about the 3-dimensional picture of this is concave, right? There's an indent in it, right? That means I'm going to either do a shell or a washer if there's an indent. Cannot do a disc for an indent function.
And you could do either.
Well, so for this one, if I tried to draw a washer, this distance would be like my R outer, or my R inner would be this distance, right? Elena? Yeah? And then this distance would be the R outer, right? Both of those are going to the same function, though. How would I differentiate R inner being this point on the function and the R outer being that point on the same function?
So we need to have that second.
It needs to have like a little hole in the middle.
So I think it must have a second function.
Usually that's if you're doing a washer, it's usually yes, there's a second function to do that. That's why this is like screams do me as a shell. Because again, like, okay, maybe you could, like, is it possible in some of these cases that I can, like, if it's a circle, I can like solve it equal to the thing and like have a plus or minus so I can differentiate like which half it's supposed to be on. Like some of that stuff we can still like cram a washer method in and make it work. But here, how am I supposed to differentiate like which half of sine of x squared I would want to be on, right? I have no good ideas on how to do that. Like I could probably figure it out and make it work, but it'd be like, it's going to be some time. It'd be like an hour.
What if who came up with the shell method?
I don't know.
Somebody smart.
All right. Try another one. We're running out of time. I'll post the rest of this to one. I'll post it in OneNote or whatever.
These are all like questions we could expect.
Yeah, I think these are like similar levels of difficulty, right? Again, notice the previous question, even though it was a shell, once you recognized it was a shell, it was pretty easy to set it up, right? Like the actual, like, oh, the just X and Y. Okay. It's like, ideally, that's kind of what you should feel. Oops.
Which one is like protein?
It's not, right? This is the base of the solid, is this. The area between this curve and then the x and y axis. And the cross sections perpendicular to the y-axis are squares. So there's no rotation going on.
Oh, that's why.
Wait, yeah, how do you know this if you don't know how high it goes?
You do.
Wow.
I thought it was 4.
Uh,
Or is it not?
Well, isn't that just,
so for example, it's saying that this here, right? So this is just like some cross section perpendicular. That's one side of your square, right? So sticking up out of the figure is something the same height,
oh, it's a square.
right? And if like this is the cross section you take, like that's the side of your square, so it sticks up that high.
Wait, so how do you, with these, how do you know what, like, what you're differentiating in perspective?
You mean integrating?
Yes, yes.
Well, here we're slicing perpendicular, right, to the y-axis. So what is the, like what's changing here? Well, we're incrementing down the y, right? The y value is deciding where we're slicing. So this is a dy problem.
The y value is determining what we're slicing.
The location of our slice is determined by the y coordinate, right? Because we're, like we start slicing here and then we keep slicing
Right.
until we get to the top. The y coordinate is what's determining where we're doing the slicing. Does that make sense?
Yes.
Think about it like slicing a loaf of bread or whatever.
Wait, why couldn't it be like perpendicular, like this way?
Because it says in the problem.
Oh,
Each cross section is perpendicular to the y.
Oh, okay. I got you.
So it tells you in the problem how to do it,
Okay.
which is awesome, right? I love it. Like it tells me the shape.
Yeah.
I don't have to think about that. Okay, squares, and tells me how to slice it, perpendicular to the y.
Oh. Are they not rectangles?
It says squares.
But like, if you're cutting that, they look like rectangles.
But it's
Or
not.
am I cutting it?
That's because how
So
tall it's gonna be, it's gonna
we
be-
do this cross section, say right here, right?
Yeah.
What it's telling you then is that sticking up out of it, it sticks up that high. The same as length as this,
Oh, yeah.
right? So it's not like you're making a rectangle in the plane. It's sticking up out of it.
Gotcha.
For X,
The other branch is 4 because that's the highest within.
That's because we're slicing on the y. So we start slicing at y equals 0 and keep slicing this way until we get to
you want
4. Because after that, there's nothing left to slice.
Right.
Dude, that's net.
And again, like this is, I think, pretty on level of the difficulty
Will
here.
we
Like,
see like one of those ones with the triangle where we had to know like the side line.
no, that was too much.
So if we're integrating for
Yeah, that was-
dy, we're changing, like, if they give you a function in terms of like y equals.
You need
you're
x
changing
equals.
it to x, if you're integrating in terms of dy.
Yes. Because you need everything, all your variables have to be y's
Yes.
in your integral, right? If you're doing dx, all your variables have to be x's.
Yes.
So if it has x equals, you have to get the y by itself.
Right.
Oh, that is what I got.
Right? It's okay.
Let's go. Should that be a dy?
Yep. Absolutely. Thank you.
Basically, like your original one, it's
I know he gave us y equals 4 minus.
Right. I'm gonna give you a little.
So I subtracted the 4 over and then multiplied by 3/4. 4 times 3/4 is 3.
You're assuming it's not one of these which tells you.
4 times 3/4 is 3.
So you have your x.
Right? Like you subtract the 4 over and then multiply both sides by 3/4. 3/4 times 4 is 3.
This, for example, we have
Yes.
y. Y.
So the area is just side squared.
X equals
I was trying to put another side there.
Yeah. No, just a square, homie.
parallel with y.
Why is it dx?
It's not. It's just a typo. I'll fix it.
Shell method? Isn't the shell method always with respect to x?
No.
No, I lied. It's like whatever it attaches to, sort of.
So if you had done the same thing, if you just had x equals sine of y squared, it's just going to look the same way, but it's stuck on the y-axis instead.
Okay.
And you do the same idea. So there, the y is your radius, and the x would be your height.
So it's sort of like whatever axis is attached to.
Yeah, kind of.
Is that what, you know, like the integrating dy solving for x thing, is that the same for like a washer, shower, all that?
What about this one? What are we going to do here?
It wasn't that.
Absolutely! Way to go. Yes, that's a polynomial division problem. You could synthetically divide it. That's okay.
Wait, is that?
I need to memorize like the
I think that is gonna be one, poly division, one synthetic division. And
No, one polynomial division or synthetic. It's the same thing, right? One partial fraction decomposition, one inverse trig.
But synthetic is just the one.
The degree is just how many x.
Typically, yes, we're using tan inverse as the inverse trig. Yep. Again, I'll post this stuff.
Can you put a little like what is this called? It's like rational integrals or something?
Yep.
Can you put like rational integrals like rule like page and then just write like if the degree of the denominator is lower, do this. If the degree of the denominator is higher, do this.
So here's what it is. If the degree of the denominator is less than or equal to the degree of the numerator,
Yeah.
it's division.
Polynomial.
Yep.
Okay. Or
If it-
synthetic.
Right.
Okay.
If the degree of the denominator is bigger than the numerator, then it's either going to be partial fraction or inverse trig. You decide based on whether that denominator is factorable.
Okay.
No,
If it's not, then you do trig.
Yes.
Okay, thank you.
Wait, what's the inverse trig?
Hi, Isabel.
Great. I just have a quick question. So, like, we had a question like this just now.
Yes.
And, like, because it literally just looks like a circle, like, how do I determine which one the radius is and then which one the height is? Is it based off of which
So,
axis you're looking at?
yeah, so if you're slicing, you're going to be slicing this direction, right? So we're going to slice on the x, right? So the x is what's changing. So we're integrating with respect to x.
Yeah.
And we're going from 2 to 4. And the radius of those slices is going to be the y value, right? Because it's up and down, right? If you drew the radius, it's like that distance, right?
Okay, yeah.
That's the y coordinate for this point. The y coordinate for that point is just this. So that's your radius.
Okay, so you kind of just, so if you're rotating on the x-axis, you're slicing on the x-axis, and then vice versa.
You're picking your slices based on the x coordinate, right? You're slicing vertically, right? But like, where am I going to slice? Where am I putting that vertical slice is determined by the
It's
x.
actually you have to do something you know to do it.
And then the radius is just, I guess if it looks like this, then it's kind of the
It's-
opposite.
Well, it's just the distance from the axis of rotation to the function.
Is it like a stats thing?
Well, couldn't
No?
that also be like axis of rotation right here to the function like.
Well, no, because if you slice this way, the cross sections aren't the same.
Oh, yeah,
Right?
yeah.
So they're not the same shape.
Okay. And then I have a few other questions, but can I come in during CT?
Sure.
I was just asking if you could check if it.
Oh, yes.